So we've been given sulfate, and so I always like to start off with the Lewis structure and adding up the valence electrons that we have. So we get 6 electrons from sulfur, and oxygen also has 6 valence electrons, but because we have 4, we're going to multiply 4 times 6, and that'll give us 24 electrons. And then we're going to add 2 more electrons, which come from -2 charge, which means that we have an extra 2 electrons, as you can see right here. So add it all up, that will give us a total of 32 electrons. And since we're doing this by pairs, we're going to divide that number by 2, and it gives us 16 electron pairs. So let's start by drawing the Lewis structure. So sulfur goes in the middle because it's the first one, and then we're going to add 4 oxygens. Okay, perfect. So since we already have 4 bonds, which has 2 electrons per bond, we're going to subtract 4. So we're left with 12 electron pairs. And these we're going to distribute to each oxygen so that each oxygen has a full octet. So let's have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Distributes perfectly. So since we have 4 bonds and we don't have any extra pairs or any lone pairs or any incomplete octets, we're going to go straight into the VSPER structure, and this Lewis structure is going to give us a tetrahedral. So for the tetrahedral, same thing. We're going to put a sulfur in the middle, and then we're going to have 1 oxygen coming up along the y-axis. The rest of the oxygens are going to go along the xz axis. So we'll have 1, and we'll make this our x-axis just to keep it simple. We'll have another one coming out towards us, and this one will be along the z-axis. Let's color it in to make it pretty. And then finally, we'll have one going backwards into the z-axis. So here we have a 3D diagram, which is a lot better than mine. And in the middle, we have, in black, we have sulfur. And then coming out of the sulfur towards the y-axis, we have our first oxygen. And so I like this one because we can clearly see how the oxygens are coming away from the sulfur along the x and the y-axis, and it also makes it easier to see the angle from the top oxygen along the y-axis to the oxygens along the x and y-axis, and they have a degree of 109.5 degrees. The degree is good to know because when we know the degree, we can see how strong the repulsion between each of the outer oxygens or the outer atoms, we can see how strong the repulsion is from them. So here's another good example. This is CH4. And we can again see how the hydrogens on the CH4, how they come out and away, not directly in a straight line. And then another interesting thing is that these are no longer straight out that way, if you can see a little better. So the question is, why are these, and these arranged the way they are? The reason that these are bending away or down from the central atom when they could be arranged straight out is because of axial repulsion. So this is the axial atom right here. And so imagine that you have two magnets. And then on one of them, you've got a positive end, and then on the other one, you've got the negative and the positive end. If you were to try to bring these two ends together, they're not going to connect. They're not going to hold on to each other. Like dispels like. These are going to push away from each other, and they're going to want to stay as far apart from each other as possible. And so the same thing is happening with these right here. This one does not want to be anywhere near this one, and these don't want to be anywhere near each other. They're trying to stay as far away from each other as possible. So these are at 109 degrees, 109.5 degrees, because that's as far as they can get away from the axial atom without getting any closer to these equatorial atoms. If they went anywhere past, if they were even at 109.6 degrees, then these would be closer to each other. Let's say that they're at less than 90 degrees. So then at 109.6 degrees, these might be at 89.9 degrees, and that's too close for comfort for them. They want this space right here to be as great as it possibly can be. And so that's why we have a tetrahedral shape where these are bent away from the central atom and are spaced as far as possible as they can from each other.